Let us read the question. We are given an equation in indices with two letters, P and Q, and we must prove a result from it. Then, separately, we have to tidy a surd expression into a standard form. Here is what we are given. This index equation linking P and Q. And here is what we must do. Part A, prove the identity. Part B, rewrite the surd in the form they ask for. So here is what we are working with. We are given the index equation and the surd expression. For part A, we must prove the identity, and for part B, we must write the surd in the requested form. The key tool for part A is the index laws, two of them in particular. The first law lets us split each power into two pieces, separating the number part from the x part. The second law then lets us group the matching x powers back together. That pairing is the whole engine for part A. Step 1. Let us expand the left side of the given equation. Start by writing the left side exactly as given. Using the first index law, split each power, separating the x part from the number part. We do the same on Q. Now group the matching x powers together and collect the leftover number parts. And that leftover folds neatly into a single squared fraction. Step 2. Now turn to the right side. The right side is the product, raised to twice the power, so we can rewrite it as the same thing squared. The equation tells us the two sides are equal, so we set our expanded left side equal to this. Notice both sides share a common factor. Divide both sides by that common factor, it cancels, and we are left with the result we wanted. Notice the proof is one clean chain, never going in circles. Just flip it round, and that is exactly what we were asked to show. Step 3. Now for part B. A quick heads up, the P and Q here are new, different from the ones in part A. Let us start with the surd. To break the surd apart, we use the surd product rule. 28 is 4 times 7, and the 4 comes out as a 2. For the fraction, we clear the surd from the bottom by multiplying top and bottom by the conjugate of the denominator. On the bottom, that gives a difference of squares. The conjugate clears the surd from the bottom, leaving 9 underneath. Step 4. Expand the top, then gather the root 7 terms. Multiply out the top so the number part and the surd part stand apart. Now bring back the 2 root 7 we found earlier and add it on. Now collect the root 7 terms. Here is the careful bit. Rewrite the 2 with the same bottom as the other coefficient so they add into a single fraction. That puts the whole thing in the form they asked for. Reading it off, P is the number part and Q is the coefficient sitting on root 7. Final answers. For part A, we proved the identity we were asked to show. And for part B, the surd simplifies into the requested form, with P the number part and Q the coefficient of root 7, both written in terms of K.